Hi, and welcome to Algebronx. Tonight we are doing a homework help video for quadratic word problems. So my students today had an assignment from eMath instruction for quadratic word problems, and many of you have responded to me that you were having trouble with it. So I'm here tonight to give you some homework tips and helps so that you're not feeling frustrated by this work right now. So, hope you're all having a good day. All right, quadratic word problems. The first problem said that the product of two consecutive positive even integers. We have to remember what that meant going back for when we were doing consecutive integers and consecutive odds and consecutive evens, and how we wrote out the let statement for the consecutive numbers. So the first thing you have to do is to be able to set out what it means to be the product of two. Now they're consecutive, positive, even. So we need two of them. We have to take a product, and I need them to be consecutive even. So we're going to let x equal the first and x plus 2 equal the second, recalling that we had to skip and not go to x plus 1 to say just consecutive, but consecutive even skips 1 and we're adding 2 to the next one. The product means we're multiplying. When I multiply, I show using parentheses x times x plus 2, the first times the second. This is the first, this is the second, okay? If I distribute, I get x squared plus 2x. Now, what about it? Well, it is equals 14 more than means we're going to add 14 at the end. And what is it 14 more than? Their sum. So I need to add, and I think I ran out of room here. I didn't actually leave myself enough space. I'm going to add them together and then add 14 more. Okay, so x times x plus 2 represents the product of two consecutive evens, is 14 more than what? Than their sum. The sum is this first one plus the second one. And when I simplify that, I get x plus x is 2x, and 2 plus 14 is 16. Okay, now we have a rule. If it's a quadratic, make it equal 0. Factor it and solve. Make it equal 0, factor it, and solve. So x squared, subtract the 2x from both sides, is going to eliminate the 2x term on both sides. And it's not equal 0 yet. Make it equal 0 by subtracting 16 from both sides. Factor it, 2 sets of parentheses. You should all recognize this. This is the difference between two perfect squares, which factors into conjugate pairs. Difference between two perfect squares factors into conjugate pairs. We can make a little song out of it. Okay, then we're going to make a t-chart. We've got x plus 4 equals 0, x minus 4 equals 0, x equals negative 4, x equals positive 4, but we reject one. Why? Because the problem said it wants them to be positive. So reject this one, and there's our answer. That's our answer for x. X equals 4. And if I add 2 more, the other one equals 6. So my two answers are 4 and 6. All right, on to number 2. Okay, number 2. The length of a rectangle is 4 less than twice the width. So what is it? It's a rectangle. Whenever you're giving something like a rectangle or any shape, a square, draw it. A picture speaks 1,000 words. It helps us to understand what we're looking at. So we've got a rectangle. What about this rectangle? Opposite sides are congruent and 4 right angles in the corners. Opposite sides are also equal. Okay, so the length of the rectangle, the length is 4 less than twice the width. The length is 4 less than, that's our switch word, twice the width. twice the width for less than equals the length. The length is for less than twice the width. So this represents the length and W represents the width. Okay? We have the algebraic expressions written for both. The area of the rectangle. Now, what do you do when you take an area? You want the space inside. You want to know how much space is inside this. Like, so you could do like square footage. If all these little boxes were a foot, you would draw these little tiny boxes and then you would count them up. Well, what is that? That's the length times the width. Area equals L times W. But L is 2W minus 4. The width is just W. And we're told the area is 70 square feet. So I don't have to write A, I just put 70. Okay, next step. Distribute. Make it equal 0, because when you distribute it, it's going to end up being a quadratic. So, usually you guys like to see that W on the left. So sometimes you could just turn it around if it's disturbing you on the right, and then distribute it in. 2W squared minus 4W. I've got a 70 here. I'm going to put it on the right. I like to see it on the right. You could do that if it disturbs you to see it on the left. I have to now make it equal 0. Why? Because it's a quadratic. How do I know? Because there's a square right there. So 2W squared minus 4W minus 70 equals 0. Now, are each of these divisible by 2? Yes, they are. 2 is even, 4 is even, 70 is an even number. So at this point, I'm going to factor out a GCF of 2. So 2 gets factored out. And now I'm going to try to factor the trinomial. So I have to think, what? 2 factors, 2 numbers that multiply to give me negative 35 and add up to give me a negative 2. Now, in order to get a negative product, you need 2 different signs. In order to have 2 different signs, it means I'm going to be subtracting. So I need 2 factors of 35 that are 2 apart. I'm hoping you're thinking 7 and 5, because they're 2 apart. And then I need a negative 2, so I need more negatives here on the 7. I need 7 to have a negative and the 5 to have a positive. So inserting them into my binomials, factors, I've got x minus 7 and x plus 5. Now I have to erase a little up here because I ran out of room. And I'm going to just rewrite what I have on the bottom. I'm sorry, not a W, that's an x. And equals 0. Okay, now I'm going to take my binomial factors and set up a t-chart. The t-chart is going to set each of the factors equal to 0. Now this factor of 2 doesn't equal 0. So if I think about dividing both sides of the equation by 2, it will disappear. 0 divided by 2 is just 0. So that factor, unless it's an x, will drop out. If it's a variable, you actually set a column for it, but it's not a variable. So we only set the columns for our variable binomial factors. X equals 7, x equals negative 5. Now, which one are we rejecting? We're talking about a rectangle. A rectangle has length. A length is something that can't be negative. So we reject the negative. X equals 7, which means, I think I changed the variable somewhere along here. Yes, I did. X is W. W is 7. And the length was 2 times 7 minus 4, or 14 minus 4, or 10. So my length is 10. My width is 7. And my given dimensions, feet, you have to answer in feet. So we're going to answer, find the width of the rectangle algebraically. It only asks for the width. The width equals 7 feet. You always want to put the dimensions in if the problem gives the dimensions. Okay, and you're done. All right, the last one I'm going to do is number 3. Okay, so this again has to do with consecutive integers. This time I have 2 sets of consecutive integers, and there's something about them. So let's check that out. All right, let me erase this. Get set up for the next problem. Okay, so the whole thing with word problems are if you take apart the words slowly and piece by piece and just go like one sentence at a time, you can do these. I know they're intimidating. I know they're usually difficult to understand, but I know you can do this. All right, have confidence, take a chance. So what if you get it wrong? Try it again. Don't give up. Just keep going and persevere through the problem because I know you got it. All right, so number 3 says 2 sets of 3 consecutive integers have a property. Now, how many consecutive integers? 2 sets of 3 consecutive integers. Well, I need 3 consecutive integers. So let n equal the first one. They're consecutive. They're not odd. They're not even. They're just consecutive, one after another. So the second one is just n plus 1. And the third one is n plus 2. Okay, so 1, 2, and 3. 3 consecutive integers. Now they have a property that the product of the larger 2, product larger 2. Okay, let's stop right there and just write what that is. Which are the larger 2? The second and the third. The product of them, that means to multiply. What am I multiplying? I'm multiplying the second and the third. And what about the second and the third? The product of the larger 2 equals 1 less than, then means the 1, the minus 1 goes at the end, 7 times the smallest. 1 less than 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 7 times the smallest. Okay, so it makes sense. All right, and now it's saying set up and solve an equation that can be used to find both sets of integers. Okay, so here we go. I want to multiply this. Now, a lot of you have been using double distributive or box method or FOIL, but whatever you use, you have to multiply the n times everything and the 1 times everything. So I'm going to use the n times the n. The first times the first is the first. N times 2 is 2n. 1 times n is 1n, and 1 times 2 is 2. If you're doing this by box method, you set up your box, n plus 1 on top, n plus 2 along the side, n times n squared, 1 times n, 1n, n times 2, 2n, 2 times 1 is 2, n squared plus, add these together, 3n plus 2. That's exactly what I'm going to get when I clean this up. What does it equal? It equals 7n minus 1. Now, you got a lot of like terms on different sides, so we're going to use inverse operations to get them together. So I'm going to minus the 7n. Why am I moving everything this way? Because it's a quadratic. And when you have a quadratic, it must equal 0. Factor it and T-chart. T-chart to solve, okay? Just always get that in your mind. So the n squared goes here. 3n minus 7n is negative 4n. I can add the 1 here and here, canceling that, making sure that side equals 0. And 2 and 1 make 3. Make it equal 0. Factor it. 2 numbers that times to give you 3. There's no choice here. 3 is prime, so 3 times 1. So I need a 3, I need a 1, an n, an n. Now, I need a positive product, but a negative sum. How do you get a positive product? Positive times positive or negative times negative. I need a negative sum, so I need negative times negative. T-chart, n minus 3 is 0, n equals 3. N minus 1 is 0, n equals 1. Now what was the criteria? We needed to set up and solve an equation that could be used to find both sets of integers. So we have two different answers, two sets of answers. And when n is 3, my numbers are 3, 4, and 5. When n is 1, my numbers are 2, and 1, 2, and 3. There are my two sets of numbers that satisfy the conditions. So we're good. If you need to put them in solution set notation, 3, 4, 5, with the curly brackets, 1, 2, 3, also with the curly brackets. Okay, well, I hope you've enjoyed tonight's video. Hope you're doing well, and stay tuned till tomorrow. As always, subscribe Algebronx for your lessons in Algebra 1 and Algebra 2. Have a great night. Bye.